Hello, and welcome to the presentation from Lab Roots, Raising Your Cannabis IQ with the Agilent IQ. My name is Sue D'Antonio. I'm an applications chemist with Agilent Technologies, and I'm based out of Cedar Creek, Texas. I'm really excited to talk to you all today because what we're going to do is we're going to take a look at some of the most exciting products that are coming out in the applied markets. Okay. Of course, our disclaimer about Agilent Cannabis Solutions, and that actually fits into right where we are today down here in Texas, where high THC content hemp is illegal and low THC, less than 0.3% by weight, high CBD is very much legal and sold it for many products here. Let's just talk a little bit about cannabis. Of course, hemp versus marijuana, and we've already specified that. On a federal level, hemp is legal across the country. Not so in the cannabis itself with the high THC or marijuana is not as legal. Now, if you ever looked at a set of compounds and said, these look like GC compounds. These totally should be run by GC. And the first time I looked at these, I'm like, you want me to run these on LC? This isn't. Look at their structures. They lend themselves to GC. There's a small problem with that. In the presence of heat, they will decarboxylate. Okay. And you can't have your numbers. There's enough problems as we're going to see discussing this without having heat decarboxylate your system, your compounds. So it's really important that you can do some GC work that has been driven as you're only as limited by your chemical creativity. But as we go through this presentation, you'll probably find out that I'm the world's laziest chemist. If I don't have to do a lot of work, I really don't want to do it. And especially for those of you who are in cannabis factories or in quality control or in testing labs, it's all productivity, right? The more analysis you're able to run, the more productive you are. So let's take a look at some different methods of cannabis. This is actually a poster that we did for ASMS. Several colleagues, my colleague Brian Whiteley has an excellent method that he's developed on the C18. Again, separation, right? The holy grail. Baseline resolution in the shortest time and cost effective. I have another customer who I'll show you some of their data that they graciously let us share, who uses our phenyl column. So, of these three methods we're going to talk about, it's a variety, right? Different column, different mobile phases. One is isocratic, one is an isogradient, and of course, one is a gradient. So, this is our third method. You can use different types of LCs. Of course, I've got the Agilent ones that we're looking at. Most of the work that I've done has been on our Prime LC, which is a quaternary pump, because again, you'll find I'm the world's laziest chemist. So I really don't want to make up a series of mobile phases. And you'll find that people are using, again, ammonium formate and formic acid. These are both mass spec friendly, but they also add quite a bit of separation. Of course, I saved my method, which I'm really pleased. These are 16 cannabinoids. And in the UV, we see that all baseline resolved. Okay. But you'll also notice world's laziest chemist has C and A rather and D being used. I have my ammonium formate in the D channel with water, of course, and I have my formic acid in the A channel. This allows me to play with the modifiers, and you'll see the excellent resolution we have on the tailing peaks at the end, okay? This is our ISO gradient analysis, and you'll see right where the gradient clicks in. We start out with, and I must give credit to Julie Kowalski. This is work based on her method. Um, we start out isocratically, and then we begin the gradient. Okay. Now, this is a standard that I worked with my friends at Sigma Aldrich in Round Rock, Texas, and this is their prototype standard that you can buy. It's a certified hemp standard, and they were very gracious to let me use it. And I want you to kind of take a look at things, okay? We're looking here at 228, and this is a way that people have been able to deal with the fact that you have giant CBD, itty bitty delta 9 THC, right? So one of the ways they've been able to address this problem is to have either a diode array or a multi-wavelength detector. So we've gone from our simple analyses to now to add diode array. And this is great because you get a couple of different signals. So what you do is you'll do your quantitation for CBD on 270, okay? Because it's off scale otherwise if you have to inject enough so that you're able to see the delta 9 THC. And in their case, they had CBN added into it in this prototype mix. I'm not really sure if that's true on the final mix that they used, but you'll see the difference. Okay. Now, this is great. Okay. You know, and you always wonder when you see real world, right? Because the real world is not standards. What we can do with standards is fantastic. Now, it would be different. This is about 11 compounds that I did, but I wanted you to show you how uninteresting the spectra are of these. They are probably some of the most uninteresting spectral compounds you'll see. For example, you'll see that we do have the acid there right around 303, so that could be CBDA, THCA. But again, highly uninteresting spectra. It's not like a really big difference between spectra. And again, these are standards. So let's look at our signal to noise ratio. We're going, in this case, it's 7.1 and 7.4. So I'm pretty confident in using these for LoD and LoQ. All right. Typically for rather LoQ. I'm a little below 10, but a little above 5 or 3 rather. So I'm quite pleased with that. But again, remember these LoQ and LoD because this is going to come in handy later. Okay. So why should I use LCMS for cannabis? Why? I mean, what is it going to really do for me? What will it add to me? Let's take a look at this. Again, a very highly uninterested spectrum, wouldn't you think? It's not really great to match. I mean, it could be a preponderance of other things. So now we look at the LCMS spectra, and we actually have, notice all the way down to the 4th isotope. So we have now firm identification of the compound that we're looking for. This is the power of LCMS. Now, of course, as I'm looking at a series of standards, you're like, yeah, okay, you've confirmed that it's CBD. I'm really not seeing why this is important. We're running standards. When we move to matrix, this will definitely become important because not only can we take that spectra, do a library search, find out the compound to add to it, but we have the capability of doing impurities and looking at those compounds. So LCMS is definitely not new. People have been using it for a long time. Agilent has a lot of application notes on that. But what we decided to do was to do a project. And this project that we began to do was very important to me. This is my standard poodle, Louise. She is the first of many standard poodles we have right now. But Louise is my first and honestly my favorite standard poodle ever. She is She was, as our breeder told me, a very poorly structured. She wasn't a well-bred poodle. So she had a lot of problems with her hips. And she was in quite a bit of pain with those hips. So we wanted to make sure that we were using a really good hemp solution for her. So I work with a customer that at that time was producing hemp solutions. It was in 2016, so it was quite at the beginning of hemp. And so we took their UV based method, and we wanted to make sure we were really, the customer that I'm working with is very conscientious that the products that they make be a true, pure, and really label claim. They actually put a little bit more in for the label. So we wanted to make sure THC, we want to make sure there was very little THC in it. We want to make sure there was a lot of hemp for it. And so we took the data and we went out and took their hemp. And not only did we do their hemp, we took several different bottles of their hemp to test not only the accuracy, but that we could all get the same results from the same batch from different bottles. And then we tested batch to batch. So this was quite, I think, an extensive test. So we took a UV based method for 11 cannabinoids because really what we expected to see in this was THCA, CBD, and THC. And CBDA. Those were the compounds we sort of expected to see. So again, this is our UV, and you're like, well, okay, that's great. You're just proving to me that I should do UV. Perhaps. But look how easy it is to put a mass spec on. You just add a simple Agilent LCMSD. They're quite cost effective. It's the same LC software, the OpenLab CDS that you're comfortable with, and it adds the power of selectivity in there. It gives you certitude, lower levels of detection, and it's a very easy detector to use. I hesitate, you think of mass spec, at least if you're a little bit older, you think of it's that magic curtain in the room like the Wizard of Oz. But this was all the data we've done was with the IQ in auto acquire mode. So we didn't really optimize for anything because we wanted it to be just like a customer would use out of the box. So these are the Agilent cannabinoid standards that we used. You can easily get these from Agilent. I just want to show you everything that we did. Okay. These are our LOQs and LODs. I want you to see that if you look at the LOD, if you remember it from the UV, we're at 2 orders of magnitude lower. 2 orders of magnitude. Now, you might ask yourself, especially if you're a hemp manufacturer, well, why do I want to pay for this? The cost of this instrument will definitely knock out your legal fees. Plus, it will give you absolute certitude because you tune your mass spec so you know the masses you're at. So you have the certitude of spectral integrity, you have the certitude of retention time, and you have the certitude of the quantitative standard that you've compared it to. It's all about being certain, right? Because more mistakes are made by being uncertain. Let me show you an example of this. This is the sensitivity. Look at the difference in sensitivity within the system, okay? You can't see it in the UV, where look at how much difference we're seeing in the time of flight. This is the 315 single ion monitoring. So what single ion monitoring is you tune your mass spec, and it's like tuning it to a radio station. It's looking at the mass to charge ratio of 315. This is the UV below. Look at the difference between the same signal. 5 times more sensitivity. That's huge, okay? Now, this is a sample of commercial hemp oil, okay? And in all fairness, this is not my customers, okay? This is some we went on Amazon, we bought hemp. We totally bought hemp, okay? Now, look at the bottom. The bottom is your UV. The top is done with mass spec. And look what we found. We found THC, delta 9 THC. And this put this product right on the borderline of 0.3% by weight. So, again, but I had someone say to me when I was giving this talk, you did 100-to-1 dilution. You just diluted it out. Now, I'm as fair as the next person, and I want to be honest and scientific. So I did a 1-to-10 dilution. And I diluted this in a commercially available 60-40 ethanol water mix that you can buy at Specs here. It's a Texas Austin product, and it's quite pure. And my customer actually uses this product as a diluent, but you can use HPLC grade ethanol or HPLC grade water. So you'll see that we actually show up the delta 9 even more with the mass spec with the 1-to-10 dilution. So that being the case, you have much more certitude that you have hemp. And you also have certitude against impurities. What was really interesting is we had a customer quanting CBD, or so they thought, and it wasn't CBD. We found that in some of the pet oils, and I will show you that. Okay, this is just the application. I wanted to show you again the LODs we did. Now, one of the other features that we have is we have the software. Now, again, other vendors have software, but I just want to show you some of the features of ours. You'll see that we have a nice linear curve. A lot of people complain that LCMSD is not linear. And I would argue that that's definitely not true. We typically get 4 orders of magnitude of linearity. And as you go down lower and lower with this mass spec, you can even get 5 orders of linearity. It's easy for your lab technicians to use. You have an acquisition method and a processing method. You can set up the sequence and it runs automatically and prints out a report. And we actually have intelligent reporting that tells you, oh, you're above or you're below. It gives you the CBD calculation. Don't forget, we have to do that magic 0.87 calculation to allow for delta 8, to allow for THCA rather. So this was the result of our 8 hemp pet oils. And I was really surprised. I'm really glad that I was giving the appropriate pet oil to my dog, because I found that for Louise, because I really found that some of these didn't have any CBD in them at all. You'll look at the one had a huge amount of CBGA. So, when you're doing QC, did it switch? Did it move? Again, this adds the certitude of mass to charge ratio. And we have very easy confirmation in your post-processing method. I was very easily able to add the mass spectra to my method. So I actually get a confirmation automatically within that methodology that I've matched the correct spectra. In fairness to the software, I also can do the same thing for the UV. So it's quite nice. I enjoy that because I am the world's laziest chemist. We add a little bit of scan. I talked to you about single ion monitoring, and single ion monitoring is the best in mass spec, and Mother Nature favors no vendor. So whether you use your Agilent or another mass spec, you'll want to do single ion monitoring for quantitative data. For qualitative data, you'll really want to look at scan, and that's a total ion chromatogram. So that's SIM is like if you're on your radio and you found the station you really like. Scan is like it looks over the whole spectra of the M over Z. So you allot a certain amount of your time to look over the spectra. And what this does for you is it gives you impurities. If you have an unknown peak, you can do a library search with it. It's really exciting. I really like a lot of these features because we had an example. We had an unknown peak and we're like, gosh, what is that? It showed up and we're like, I don't know what it is. So we did a library search and we found that we had a little bit of caffeine in there, an aspartame, and a few other features in the product. So it allowed us to simply do searches, and it's connectable with the NIST library. So it worked out quite well for us. One of my favorite customers. Donna Payne is a consultant. You'll see her on some of the Agilent application notes. If you're looking to do anything with compliance or the word that no vendor will ever tell you we do, the validation piece, Donna did an absolutely fantastic webinar, and the link is here. So I'm hoping that you can click on the link and get to it. But what I really wanted to show you is what she shared with us. She does her THC. This is their ISO 17025, their round robin compliance where I'm sorry, not round robin, their compliance sample that they sent to them. Look at 1.2% for the Delta 9 THC. That's fantastic. I mean, that's spot on with the accuracy. Also, we do give a free ISO book, a GMP book. So if you're ever interested, that's on the Agilent website. Everything I've talked to you about, and I think I've gone rather quickly as I'm discussing with this, so I hope you've caught everything, is in our application note. I've put the link to the application note, all the work we did with the pet oils, and then Agilent's, of course, link for potency testing and other testing that you might need. The little puppy is Sir Isaac Newton. He was dropped on his shoulder when he was a puppy, and he did a little bit of rehab. So the combination of therapy in the hydro pool and a little bit of CBD oil to let him get through the pain so he was able to work, helped him, and he went on to Chicago. I don't know if he's forgiven us for sending him from warm Texas to Chicago, but he did a really good job. So thank you very much for your time today. And if you have any questions, please let us know.